So what we're going to do today is we're going to take this piece of aluminum square material here and we're going to machine it into a 975 thousandths cube. To do that, we're going to be using this vertical mill with a 1/2 inch end mill and various tools that we need to do to be able to do this, okay? So the first step we do is, I've already pre-cut this piece of aluminum to 1 inch square. Now, 4 of the sides are off the mill. So they come that way from the manufacturer, whereas we've got 2 saw cuts. When we start with this, the first thing you need to do is get your trusty Sharpie pen, okay? And we're going to inspect all 6 sides. Now the two sides that are saw cut are not going to be usable for this first step because we need to have something that's kind of true. And the 4 sides that come out of the mill are the truest. Now they're not perfect because of the manufacturing process. They might be wavy, they might be bowed, they might have a dish in them. So what we need to do is find the best of these 4 sides. Okay, and as I inspect this, I've decided that this side right here looks like it's the best one that we've got, so I'm going to mark that. With this side here, then I'm going to elevate it up in the vise using parallels. Now I'm only going to use 1 parallel at this time. These faces are not perfectly square, so I can't clamp on them in the vise in an untrue state. So what I'm going to do is I'm going to put a parallel in here on one side and give it a pivot point to rock on. All right? So we're going to put this in the vise and it's going to reference off of that face. Now, the problem we have with this setup right here is that the 2 sides that are being squoze on by the vise are not true. So if this one and these 2 vertical faces are not parallel, it can skew the way the cube is being held in the vise. So what we actually need to do is put a piece of material in between this movable jaw right here and the part. A lot of people like to use solid lead solder, okay? I can never find solder when I need it. So but I always have a set of parallels with me when I'm doing machining on the mill. So I like to take the shortest parallel that we've got and I put it in the middle of this face right here, this vertical face here. What we're doing is we're taking and putting pressure in the middle and we're triangulating and pushing that force against this face. So this becomes our reference face, which is truly straight up and down. It's referencing this face and this face of the block. And then I'm going to tighten it down. Now, when we tighten something down, this isn't where we're not ready to start machining quite yet. We need to tap the vise, this part down into the vise. If you notice, this parallel is moving around freely in here. This parallel is what gives us the reference so that this face here and the bottom matching face is parallel to this table right here, which is our reference. Okay? So we're going to take a dead blow hammer and we're going to tap this down. Now, dead blow hammers have a hollow head in it that's full of shot. What they do is as it swings and when the hammer hits the table, this shot has been held back just a little bit due to centrifugal force. And when it hits, then the shot comes up and it gets a double hit. And it prevents this hammer from bouncing back. So when you're tapping something down with a hammer, you want to tap it down. Let's get this over where I won't hit anything. Okay? So when I tap this down, did you hear that snap? That was this piece being forced down against the parallel. Okay? Now that parallel is cinched in there nice and tight and is creating a nice flat reference face for this to be machined off of. Okay? You do not need to whale on this thing like you're trying to drive railroad spikes into a railroad tie. Okay? You hit it hard, it's going to bounce back up. Okay? So you don't want to hit it hard and let your hammer bounce up. You want to drive it down and keep your hammer down tight. So we're going to tap that down. You don't need to beat it. Just tap it down good and solid. Now this is tight. One of the things that you usually end up doing is you tap it down and then you go, oh, I'm going to tighten the vise up a little bit more, okay? Whenever you tighten this vise, this jaw has a tendency to want to lift a little bit and will lift this up in the vise. So if you move this and tighten this jaw up, you're going to have to come back and tighten it back down, tap it back down to the parallel. So now we've got a nice flat face, a nice vertical face, and this piece right here is forcing the material, triangulating it against that point, against this face, so that now it's nice and tight and solid. At this point, we're about ready to start machining. I've gone through and done the cutting speeds for this, so this is going to be rotating around 12 to 1500 RPMs. I've got a 1/2 inch high-speed steel end mill in here. Now, the first step that I'm going to have to do is I have to find my reference for the end of my end mill. So I'm going to reference this tool, put the tool right over the top of the aluminum cube. I do not want to loosen the quill and bring this down and touch the top of the material. You can damage the tips of your cutting tool and dull it and make it where it's not going to cut efficiently. But I can bring this down close and not touch it. Be sure to lock your quill in place so that it doesn't move. You don't want this thing lifting or dropping while you're doing it. We take a piece of paper and slip it in between the material and the end mill. Paper runs about 3/1000 thick. So as I lift this knee up, the part's going to come up towards the end mill, and as I'm moving this back and forth, all of a sudden you can see I'm getting resistance. I'm feeling drag across there. That tells me that the tool is 3/1000 away from the top of the tool, the part that I'm going to cut, okay? Now, we have to think this through a little bit right at this point. This part is roughly 1 inch in thickness, okay? I'm trying to go down to 975 thousandths thick. So I've got roughly 25 thousandths of material to take off of this piece of aluminum to get it down to size. So usually what I like to do is I like to come in and drop down about 5 thousandths and make a very light cut across this top of this part and find a reference height, okay? So by using this knee right here, I can set my 0 point and I can lift it up the 3/1000ths that the paper thickness. Now the end of the tool would be touching the top of the aluminum, and then I'm going to go down another 5 thousandths. I'm going to take a 5 thousandths deep cut in this, okay? And now we're going to turn this thing on. And you can see it starting to cut the top of the material. I like to stagger across this thing and do half of the cutter width, which is 500, so about 250 thousandths step over. That allows the tool to cut and give us more chance to take out any inconsistencies in the part and make us have a nice flat surface. Now my OCD steps in and I have to step it all the way across, because then the tool pattern that you can see materializing here, you can see I've got vertical lines banding across there. I like to step all the way across the part with the cutter so that we have a nice, even, flat face, okay? Now I've got this part here finished. The surface has been machined flat. I can take this part out, and now I can see I have a nice flat face instead of this face here that's really rough. This face right here now has become my reference that I'm going to build the rest of the cube off of. So I'm going to put a number 1 on this face. When I get done, I'm going to have 6 faces numbered on this. So at this point now, I'm going to rotate this new reference face against this jaw here. Always remember to clean your machine in between cuts. You wouldn't think about it, but a little tiny piece of aluminum in there can lift the part and make it not be flat and square. So now I've cleaned the chips up. I'm going to put my parallel back in here, put my reference face. I like to put the reference that I used in my best face down, okay, because that was originally my best face. So I'm going to use that as my secondary reference. I'll slip this in here and tighten it up. Now I've got to come off the side because once again, my parallel's not tight down in there. That's my reference for my flat surface. We'll tap it down in. Now notice when I was tapping this down in, I was only hammering on this one part right here. That's where my reference is. If I hammer on this side, it could have a tendency to make the part tip down. So I'm only driving that down over the top of the parallel where it's going to come in, tap in tight. Okay? Now, I'm ready to cut this next surface. Okay? Now, I was referenced off of the 1-inch square aluminum and I took 5/1000ths off. I should cut off of this face because this piece here is 1/1000. So I'm referencing off the bottom of the part right here. Okay? All right. Now I've got 2 surfaces. One of the things that we need to do, and I forgot to do it on the first piece, and this might come back and bite me a little bit, but after each cut, you're going to have burrs that form. You have to take a file and round all the corners that you just machined and deburr those corners, because the burrs on those corners can cause the piece to be tipped out of squareness. Okay? All right. Now I have one face here. This is my reference face. Now I have another face. This number 2 face that I just did. Okay? These 2 faces here should be perfectly perpendicular to each other. They should be 90 degrees apart. After I've done number 2, now I'm going to move on to doing my 3rd of the 6 faces that I'm going to be doing. Once again, make sure we clean all of the chips out. Okay. Put our parallel back down in here. Now, number 2 used to be up. Now I'm just going to take and rotate this down and put number 2 down, still using number 1 as my reference against the face of the mill vise. Once again, I'm still triangulating. I do not have completely true faces yet, so I'm still only using one parallel out here. Now, this face here, with the first 2 faces, I didn't make any vertical adjustment. That's because I was starting with a known size that was the same on both of them. But now I've taken 5/1000ths off of both these pairs. If I run across right here, I should not touch and cut any of the aluminum off, okay? So I'm going to have to lift it once again to take some material off of it. Now, remember, we said we only had 25/1000ths to work with. I've already used up 5 of it, so I've only got 20/1000ths of material still to take off. Don't get greedy and take off more than you need to. Take it in baby steps. Go slow, okay? So what I'm going to do now is I'm going to lift it another, I'm going to lift it 10 thousandths this time, okay? So now I should end up with a part, I should cut this off this face, okay? Turn it the right direction. Okay. So I'm staggering my steps across this face, and I'm cutting this material down to size, okay? You take the part out, and then once again, I'm going to deburr the burrs, file them off. Now there's lots of different techniques to deburr a corner. Some guys like to just do a 45 across there, okay? Just knock a 45 onto it. But there's a chance too that when you do that, you can shoot a little burr with your file. So the way I like to do it is I'll knock a 45 onto it, and then I'll come back and I'll roll that corner with my file and put a little radius on that instead of a chamfer on the corners. Okay. And now I've got a burr-free corner. Now, I've done number 1, number 2, and this was number 3. Okay. Now, when I did number 3, what I have done now is I've created 3 faces that are perpendicular to each other. Okay. But number 3 and number 2 are now parallel to each other and machined flat, so they should be perfectly parallel. So from the rest of this point on, when I'm doing the machining, I won't be using my additional little spacer bar. I can actually use 2 parallels because I have those 3 faces all perpendicular to each other. Okay. Once again, we've got to get those chips out of there so that they don't affect it. Okay. I'm still going now I'm going to put my reference face that I machined these 2 with. I'm going to put this one down on my parallels. It's all about referencing and using known references. Okay. So I put number 3 against number 3 and 2 are vertical, and my reference face is going to be down on the 2 parallels. Now, if I did this right and everything worked out nice and perpendicular, both of these parallels are now tight. They aren't moving. That shows me that the 3 faces are perpendicular to each other. At this point now, I can come in and I can mill my 4th face. All right. Once again, I'm going to deburr these 4 corners. Now, one of the things you'll catch machinists doing all the time is you think we're sitting here fiddling around with these cubes or these pieces of material that we're machining. Actually, we're not fiddling with it. We are feeling for burrs. We're always feeling sharp corners, looking for burrs. So if you see us with a piece and we're playing around with it in our fingers, it's not that we're playing with it. We're actually looking for burrs. Okay? So now I've got 4 faces that are parallel and perpendicular to each other. Now we have to attack these end pieces. Okay? At this point, I'm going to put my number 1 face back up against my vice jaw. Tap it down, Okay, the parallel moved. Something's not right down in there. And I see I missed some chips. Okay? Don't be afraid to pull a part back out. If it's not sitting right, it's not right. So we've got to make it right. Okay? So I'll put number 1 back up in there. Push this down. Okay, so now the part is seated down tight against both parallels. Neither parallel are moving. What I'm going to do now is I'm going to tack this saw cut edge, but it's in a vertical orientation. I actually have to turn the part 90 degrees to be able to do that. Now, there's lots of ways to go about doing it. One way, I can take this machine face and set up and put an indicator on it and dial this face in vertically and then machine the top. But for the project that we're doing, we're just making an aluminum cube to make a Turner's cube out of. We can do a little bit of a shortcut. Now, this means that I've got to have dialed this mill and vise in perfect. I trammed the mill in to less than a couple of tenths out of square, and I dialed this vise in to where it's only a couple of tenths out of parallel to the table travel. So that means that my X, Y, and Z axes are all going to be perpendicular to each other. What I'm going to do is I'm going to come in here, I'm going to lift the knee up, I'm going to reset 0, and I'm going to lift the knee up 200 thousandths. 1, 2. And I'm going to side pass a little reference cut across here. All right? Now the reason I'm doing 200 thousandths is because these parallels are 1/8 of an inch thick. They are 0.125, 125 thousandths, okay? So I'm going to come in here, I'm going to what we call side pass, okay? I'm going to turn the mill back on, and I'm going to make a light cut across the side of this, all right? Now this is a great opportunity to show you the difference between climb cutting and conventional cutting, okay? Now, this part right here, this now has created a reference face for me. Take the parallels back out, okay? Make sure they're all out. Now, since I did this reference cut right here, I've got 2 different sizes, so I can't use both parallels. I'm going to switch back to putting just 1 parallel in here. Okay. Almost forgot to deburr it. If we don't deburr it, it's going to knock it out of square. Okay. All right. So now I'm going to put this back down in here, reference off of 1 face. I've got machine surfaces, so I don't need to put my spacer bar in here, but I do have to tighten up that parallel and get it good and tight down in there. Okay, once again, we're tight. Now, remember I lifted the knee up. I took a 200 thousandth depth of cut. So at this point, I've got to drop the knee back down 200 thousandths and come back up to my 0 point. Now I'm at the exact same spot for height that I had when I did my last cut. All right? So I'm not cutting on this surface right here. I've got to lift this up just a little bit. Until I cut that material, okay? I'm gonna have to lift it just a little bit more. There we go. Now what we're going to do is we're going to bring this into final size. I just measured this with my calipers, and this dimension right here is at 966 thousandths, okay? I'm going to put my parallels back in here and put this last face up with the step that had my reference on here, okay? Tap this all back in. Both parallels are tight. Now, this step I'm going to do right now should cut right across this face that I had used as a reference, all right? When I get done with this, I'm going to have to make 3 more cuts on this. I'm going to cut this piece right here, and then I'm going to rotate it and cut one of the other 2 pairs, and I'll rotate it a 3rd time and cut one of the other 2 pairs that is left. By doing it this way, I've made it so that I do all of my final cuts to bring it into size in a vertical orientation. But I only have to set it 1 time. I don't have to come back and do each face and bring it in to dimension. It should stay nice and flat and parallel. And since I'm not changing it, it should cut the same dimension all 3 cuts, okay? Now you see I'm making a heavier cut on this one than I did on any of the other ones. Aluminum's really soft and it's really nice to machine, and it's easy to take heavier cuts, okay? So I'm allowing myself the opportunity to bring these all to size and not have to worry so terribly much about deep cuts. I'm going to deburr this one. Now this is nice now because I've got all of my I just did my first pair. Now I'm going to use a micrometer to measure this. I like using my calipers for reference, but as we know, calipers are not the most accurate. I want to use a micrometer. I can see that I'm sitting at 962 thousandths. Okay, 962 and a little bit, 963 and a little bit. We're a little bit out of square on this one. I think I've got a burr down here. So I'm just going to run a file over this and make sure I got all the burrs off of it. I'm going to come back and double check it. And now I've got 980, 989, 984, 984, and 987. So we've got a little bit of variation going on here, but I'm shooting for 975, so I'm still high of my dimension that I'm looking for. So with that being said, now I'm going for 975 thousandths thick. If I'm sitting here at 986 thousandths, I know I'm 10 thousandths high. So I need to take another 10 thousandths off of this part and come down here to my knee, and I can lift it up 1, 2, 3, 4, 5, 6, 9, 10 more thousandths, okay? Let's clean this out one more time. Want to take and make sure that we don't have any chips in there, because I think I had a little chip in there on that last cut that made the part sit crooked. Okay. I'll put the cube back in here. Tighten up my vise. Can't get a good swing on it. Tap it back down in. The parallels are all nice and tight. I've hit all 4 corners. Just one point of safety. Make sure that you always have the spindle stopped right here. Have that stopped before you ever get your hands down in there, because end mills do not take little chunks out of you. They tear fingers off. Okay? Now, so I've cut that face again. We're hitting at that within 1/1000ths all the way around all of these. So now I've got this all set. Now I can just take these pieces and rotate them around and put one of, I'm gonna take one of these. See, I've got 1, 2, 3, and 4. I can now put number 3 down and number 2 will be poking up. Okay, this is a great indicator as I'm going across here, because when I do 3 and 2, one of these is going to disappear. When I do 1 and 4, one will disappear. And that'll give me a visual ID that I've done all 6 sides. Okay, all 3 pairs. Okay. Tap these down. One of these parallels is moving. Okay. This is a good indicator that that's not quite square. So I'm going to take this out and flip it over and put number 1 up. Tap it down. Number 4 was square, but number 1 was slightly not square. Okay? So if you listen to your machine, it'll tell you things that you wouldn't normally notice. Okay? And by seeing that one of those parallels was loose underneath there, I knew that face wasn't square. Okay? All right, so I just did my second pair of sides. I'm going to deburr it. And now we're sitting at within 1/1000ths of the other side. 955 on that side and 954 on that side. Okay. Now that leaves me one more pair that I've got to do. I've got 2 and 3. So I'm going to take this back in here. Clean out the chips. I'm going to put number 2 down. Once again, I've got just one that's not quite tight, so I'm going to flip this over, put the opposite side, the one I had down, put it up. Okay, and now I'm machining at fast pace. And now I'm sitting right at the 955 dimension. So I'm within a thousandths on all 6 sides, okay? So now I've got a cube that is cubical. It's 955 to 954 on all 3 pairs. So that's how we go about squaring a cube up, making it perfectly cubical, and allows us to be able to have a part ready to make a Turner's cube out of.